Okay, got it. Okay, so the yellow hexagon is one whole cookie. How many whole cookies do you think we have?
So this is like estimating, basically.
Actually, you can move around the pieces.
Okay. I'll try and make this way. It was just so hard. Oh, wait, I got it. I need 6 to make one more cookie. But how many pieces do we have? Right here. So we either have 6, we have 6/6 of cookies, or we have 2 wholes and 1 half. That's what.
Are there more or less than one?
Hmm?
Are there more or less than one whole cookie?
Are there more or less than one? There are more than one whole cookie because because there's 2 wholes and we have a half.
Good.
So it's 2 1/2.
Can you write that number that represents the number of whole cookies and how many are left?
Yeah. So we got it's 1 half and 2 1/2.
Nice, good job.
That's
How do you say this fraction?
This fraction?
Mm-hmm.
1/2.
And how do you say this whole fraction altogether?
2 wholes and 1/2.
Nice. What do you call the top number in a fraction?
The top number? The numerator?
And what do you call the bottom number?
The denominator.
Nice. And what does the numerator mean? What does it represent?
It means how much is there, and the denominator is how much pieces. Well, the numerator is how much pieces you have, and this is just the whole.
Good. And what do you call this number over here? What does that represent?
It represents 1 whole. So it's like one whole thing because of this right here is because since you can do this also 2 ways. You can also do 2 and 2 because that also is 1 whole.
Mm-hmm. Good. Can we do another one?
Yeah.
You did a great job. You can erase the board and I'll take these. Okay. New pieces. These there, and these here. The yellow hexagon makes one whole cookie again. So how many whole cookies do you think we have now?
Here I can do this. Also, so then I can add the laser to 6. So we have 2 holes also. And this time we have 1, 2, 3, 4, 5, 6. Or we can do like we have 2 6 and 1/2.
Nice, good job. I like the way you thought about that. Is this more or less than 1?
It's more than 1 because we have 2 holes, which is basically more than 1 because it's 2. 2 is better than 1. And also with the half, or it could be 5, 6, or with the half and 2, 6, it's just going to make it even more bigger.
Can you write this fraction with the marker for me?
We'll do it this way right now. So now it's 2 and 5, 6. It's like the other one. It was close to a hole, and this one's close to a hole.
Nice. Good job. Okay, now we're going to look at some pictures. Ready for it? I think you're ready. Go ahead and erase your board. I'm going to do this one first. What kind of a model is shown in this picture?
Like a picture model, I think? Yeah, it's a picture model.
Can you write or model this fraction shown in the picture?
Yeah. So it's basically, we know that's cut into thirds because each one has 3 pieces. So I'll just group these together because I know these two are wholes, and I'll group them into 2. And this one I see that's left with only 1, so it's going to be 2 thirds.
Good job. Can you model it in a different way?
Yeah. I can basically model it in this way. So, what my teacher also did is that, so she gets, basically it's like the same as this.
Mm-hmm.
So then we cover this up, and this up. Oh no, this whole thing up also.
Mm-hmm.
And then so that's one hole. This is another hole. And this is 2. The other way my teacher does it is like, if it's like one hole and if it's one hole and 1/3 and 2/3, then what she would do is, oh my god, is this? If it was one hole and 2/3, then she would just do this. So that's like this. And now I'm not gonna draw another one, but she does this, and then she just adds the 2 other ones, and then just puts it there, which is basically 2 holes because she's adding them.
Mm-hmm. And then what do you do with what's left?
Well, you just don't. That's the sum basically, because they said it was 3 holes and then 2 holes. Basically you could have said just but if they said like find a new answer, except like 1 hole, 1/3 and 2/3, or you can just do 2 holes because you added the 1 hole and the 1/3 and the 2/3, which basically makes a hole.
Nice, interesting. You want to do another one? Okay.
This one's with 4.
Mm-hmm. Same thing. What kind of a model is that?
It's a picture model.
And can you write that or model that fraction in a different way?
So we know it's 4, it's just cut out diagonally, a triangle, basically. So it's 1 hole this time, and 3/4. Now this time we'll fold.
Nice, good job. Can you do it in a different way?
Yeah.
Model it in a different way?
You can do it in a different model. Well, it's basically the picture model. Picture model will always help. You can also do these with rectangles also. You don't have to do it with squares. Or you don't have to do it with... You don't have to do it with squares or... You don't have to do it with squares or circles. You can do it with rectangles also.
Mm-hmm.
So now I'll cut this into 4, which I need to cut it at 3 lines, and then 1, 2, 4. So then the same thing with this. Oh, that's 6/3. They're not equal. And there. 1, 2, 3, 4. Now you cover this up. Which is 1 hole, and you just cover 3 of these, which gives you 1 hole and 3 fourths.
Nice. Can you show my camera?
Huh?
Can you show the camera? I'll hold this. Nice job. All right. You ready to do another problem? Okay. Erase your board. Okay. I'm going to write a problem on your board. Or I'm going to write a fraction.
So 7. So what I can already see right here is it's an improper fraction.
Yes, you can. Nice. Good job. So, can you write an equivalent fraction to this?
Oh yeah.
Yeah? What was my question asking you?
So would you want me to write an equivalent fraction, which means basically the same, a different fraction, but it's the same thing as this equivalent fraction.
Nice. All right. So, what are some equivalent fractions to 7/2? Or 7 halves?
Okay, so you can do so basically I would just do this. So I take this 7, just put it right there. And then I count so 2, and 4 and 6, and then I'll stop there. So then I can know that this is 2. So then when I get to so now this is gonna be 1 hole, then 2 holes, and then 3 holes. So we have 3 holes this time. So I'll just draw 3 holes, and I'll draw 1/2 because since it's 2, and then since it was only 6 for the 3 holes, then you only have 1 more, so then you just do it.
Wow, nice. So you did 2, 4, 6, and you stopped there, right?
Yeah.
You put it over half. Nice. Okay. Is this, what do we call this? You told me this was an improper fraction, right? What do you call this fraction?
This is like a regular fraction, because it only has like a bunch. It has holes, and it's not like going over the line from the denominator. But this one is going over the line from the denominator.
You ready to do another one?
Yeah.
Okay, go ahead and erase your board. I'm going to write it on your board again. Same question. Oops. There you go.
So 13/4.
Can you make any equivalent fractions to that?
Yeah, this will be like a big equivalent fraction. So I'm going to do, so I know that 4, I'm going to do this with times. So I know that 4 times 3, well, so like I'm using these 2. So I know that 4 times 3 equals 12. So that means I know that I'll have 3 holes now because you have 3 groups of 4, and those are basically 3 holes because we have 4. So now I have 3, and same thing like last time. We have it's the same thing. We have 1 now because it's 13, which these are not equal fractions also, 7 and 13. And it's 4, so it's basically the same thing, just with 4s.
How do you say that fraction?
3 holes and 1/4.
Very nice. Good job. Is this a fraction less than or greater than 1?
It's greater than 1 because you have 2 more holes than 1, and you also have 1/4.
Very good. 1 more question. Well, two actually. Go ahead and erase your board. Can you create a fraction that is greater than 1 for me?
Yeah.
Can you create a fraction smaller than 1 for me? You are all done. I am so glad to hear your thinking. Can you wave to the camera? Bye.
Bye. What's 15 minutes?